Mining trucks operate in some of the harshest conditions possible, where grit, chemicals, heat and moisture can accumulate and impact on the operating life of wheels. As a global leader in off-the-road tyre applications, Bridgestone understands this unique environment. The company contributed to the development of the standard for wheel testing and repairing, and solutions that are focused on operator safety and return on investment.
Well, basically the trucks have got really big over the last 10 years, and of course the rims have to get bigger too, because you only still got the same 6 rims. Of course this causes a big increase in air volume and therefore poses a lot of safety concerns. So it's necessary to enter into test cycles to be able to make sure that we've got some confidence with safety on rim product, but at the same time this would also help reduce the cost per hour of running rims.
A 3-year period in a mining operation can equal 15,000 hours work for wheels and components. And as wheels advance in life, regular checks should be undertaken to look for signs of fatigue or failure. That's why Bridgestone has invested millions in technology and staff to inspect, test, and if necessary, refurbish or repair wheels for customers. The process starts with stripping, washing, and surface blasting the wheel and components to remove all foreign materials, including oxidation. Then Bridgestone's highly trained wheel staff look for the telltale signs of fatigue.
Well, of course, we're always looking for cracking, and there's prominent areas for cracking, the circumferential welding, the gutter sections, the back sections, and then we have got to look for wear, corrosion, galling and fretting. And all of these things are repairable and can reduce the cost per hour dramatically if the wheel is entered into a correct test cycle.
Critical areas of the wheel and rim base are checked using a magnaflux process. A white background is applied, and using a metallic solution and magnetic field, crack-like indications can be easily identified. Ultrasonic testing can be used for unusual flaws if needed. If the wheel gets a clean bill of health, it is washed and painted, ready for return to service with the client. If a crack has been identified and a section replacement is possible, the failed section is first removed using plasma technology. This cuts cooler, lowering carbon impregnation of the parent materials. A weld prep is performed to enable an internal and external weld around the circumference of the repair to the identified standard. The new section is coaxially aligned before the wheel undergoes semi-automatic submerged arc welding. The new welds are then stress relieved using in-house shock peening technology, and the lock ring groove is treated with enriched zinc to delay the oxidization process before the wheel is painted and packaged, ready for service. The case for repair is compelling. If a 57-inch wheel, for example, suffered a section failure at 12,500 hours, it would have cost the operator almost 69 cents per hour. If it could be repaired and run for another 10,000 hours, the running cost for the wheel would fall dramatically by around 55%. And that's not the only reason for regular inspection and repair of wheels.
The pressures nowadays on rims is phenomenal, and the chances of catastrophic failure is very, very real. And of course we know what sort of damage that can bring. So safety is number one. It has to be number one every time.
Regular inspection and repair of wheels not only reduces operating cost and enhances productivity, it also ensures total peace of mind.